putting these values in for x, okay? So we're going to first find h of 100. Okay, and that's 0.003 100 squared plus 0.07 times 100 minus 0.027. Is that okay?
Yeah, that's okay. I'm gonna go put
All
this
right.
in the calculator.
Yep. And we're going to do it again for another value. So it's
So when I do the h in parentheses 100 equals 0.003 100 squared, I got like 99.73.
okay. That is not correct. So go ahead and check your decimal places. Double check that you've got it written, you put in the calculator exactly the way I've written here.
Yeah, I'm just double checking. Okay, so I messed up on the decimal places. It was on the 0.07. So instead I got 36.73.
Good. Okay, now you're going to do the same thing. 36.973. You're going to do, you will do the same thing for 80.
Okay.
So go ahead and do that and give me your final answer.
I got 25.93.
Okay. Yeah, we're just off again. So give that just another try, please.
Why do I keep messing up? Oh, I see what I messed up. Okay. Okay, now I got 24.54, 55, no, 53. Oh my God.
All right. Are you set on your you set on your final answer there?
24.53. There you go. Set it right.
Again, we're still off.
What
I
was
don't
I
know.
off on? All right. And I wrote everything right. So what am I off on?
Not sure.
I think I know. Wait, no. That's strange because when maybe I put the decimal place. No, it isn't wrong. I put it in the correct spot.
Okay, well, because the answers are going to be, the answers are far enough apart, you're not going to probably see a big difference. But to find the average rate of change, you want to take the first number you calculated, subtract the second number you calculated over 100 minus 80.
So now I just have to subtract those two decimal points
And divide.
and divide. Yeah.
You can enter all this into the calculator at one time.
got 0.59785.
So which of these answers would you choose?
0.61.
Yes. Now, if you did enter it in exactly like this, you would get exactly 0.61. There's still something happening. I'm not sure if you're not writing it down or there's something happening. And I mean, it's not a big deal for me, but it could be an issue for something else. So
Yeah. Like,
imagine that we were calculating, billions of dollars in profit that we were dividing out. It's be off by 0.2 of a hundredths, and the billions would be a lot. So just maybe just double check your numbers there. All right. So here is a new problem from geometry, which we have not done
yay,
any geometry,
geometry.
but yeah, but this is something you see on standardized test. So it says in a circle, the length of an arc intercepted by a central angle is 12 millimeters and the radius of the circle is 8. So here's a picture of what's going on. It's a pizza slice. And there's the center of the circle right there. And they're saying the arc is up here. It has a measure of 12 millimeters. And the radius is going out from the center to the edge. There's actually 2 radii here. You've got one down here and one up here. It's got a measure of 8 millimeters. Now there's a simple formula here that you were given in geometry, which is that the arc length equals the radius times the angle. S equals r theta. You're given the value of S and the value of R. Do you agree with that? That's S, the arc length, and that's R,
Yeah.
8. So you have 12 equals 8 times theta. Theta is just a Greek letter. No big deal. It's just like X. Okay. How do we solve this for theta? How do you undo this number in front of it?
Like, how do we do 8 times 0?
How do you? It's not 0. It's not 0. What
Oh,
did I call it? Or what did I kind of say that it is? The same as.
I. Oh my god, what do I keep forgetting things that they always say?
It's a variable. It's some sort of variable. If you don't like theta, you can call it X. Okay.
I'll call it x.
Okay. So how do you solve for X in this equation?
You divide by 8.
Okay. Divide both sides by 8. So give me the reduced form of, so what is 12 divided by 8?
3/2.
Okay. Is that up here in the answers?
Now,
Is there anything close to it?
1.5.
Yes.
Huh, yay.
Which is the same as 3 divided by 2, just in a different form.
Oh, really? That's cool.
Okay. All right, boy, these all require kind of a bit of explanation to do. All right, so just need to quickly graph this because I want to give you kind of, they're giving you what I'll call the exception cases in some of these, which isn't all that helpful. It's not helpful either. Okay. All right. So let's do this. This is the question, but what I want us to focus on is just the function. I'm going to snip in just the function next. Is already there. Let me grab another snip, grab too much. Okay. All right. So this is the function. I want you to evaluate f of 1. We just did that in the problem with the horsepower. You're just putting 1 wherever you see. And can you do that for me, please?
Sure. I'm gonna have to graph this. I don't know why I was putting in the scientific.
You don't have to graph it. You're just putting 1 in for X. You're giving me a number at the end.
Okay. So the answer for that is 20.
Try again. You've
Oh.
got to enter it exactly the way that it would be. And when you substitute for letters, not variables, it's good to put it in parentheses.
Yeah.
Parentheses implies the multiplication. Calculator knows to do the exponent first.
Yeah.
So give that one more try, please.
So when I did everything, I made sure everything was correct. I keep getting 12.
Okay, 12 is correct.
Yeah. I was just afraid I got it wrong.
So last time I heard 20, which is not the same as 12. So yeah, this is correct. Now, what I'm going to show you next is what's called synthetic division, which I don't remember if we never covered it, but it doesn't mean that it wasn't covered before we started working together. So the way synthetic division works is we write the coefficients 3, 8, 5, and -4. You write the coefficients, and then you start by bringing this 3 straight down. Then you take this 3 and multiply it by what's in the box. And it's -1 instead of 1. We'll get to that in a moment. I'm sorry. Forgive me. That is not what I wanted. We want +1. 3 times 1 is 3. Now we're adding vertically. Okay. 11 times 1 is 11. Adding vertically. 16 times 1 is 16. Adding vertically is 12. Do you see that these are the same? This is what's called the remainder.
Mm-hmm.
And the remainder is a point on the graph. So there's a point on the graph 1, 12. So when you have a remainder, it represents a point on the graph. Okay.
Mm-hmm.
So in this problem, I'm going to resnip it in. So this time the student divided this function by x plus 2 and found that the remainder was -6. This is the y value. It's the y value. So there's an ordered pair here where the y value is -6. Right. The x value comes from this, and it's a little bit awkward. You actually set it equal to 0, sort of backwards. It's not 2, it's -2 because the factor and the 0 are opposites, basically. So to summarize, I'm about to show you the answers. This point is on the graph. This point is on the graph. Okay. So let me snip in the answers and see if you can See if you can see which one says as much here. I don't know if I can do much more than that to help you answer this, but go ahead and take a look at those.
Okay. Let's see. So like, wouldn't it be on the point -2 comma -6 slash in the graph of like f in parentheses x? Yeah, that
Yes,
one.
yes. All these other ones are possibilities, but
Yeah.
there's a lot of like it's really like four separate questions that they're throwing at you here. So it's some ways it's really challenging, but that's okay. All right. So this, I mean, this is yet again a problem you have not seen. We didn't cover any of this. This is this is algebra. This is trigonometry. You didn't cover any of this in your class, so I'm not sure how to proceed here, but we can do this. We can do this in pieces. So a right phase shift of pi over 4. Okay, we looked at this earlier. If something is going to the right, in parentheses, it's x minus. And if it's left, if something is going to the left, it's x plus. Remember that? We talked about that a little bit earlier in our lesson.
Yeah.
So this one is going to the right. This one's going to the right. So it's going to be an x minus inside parentheses. Which of these four answers has an x minus? Which of these four has an x minus in there?
Yeah, the last one. Well,
This one
wait.
on the right?
Well, you said -4. I actually said be the second one.
I just said minus. Which of these four has an x minus in it?
Yeah.
Would it help if I type my questions? I feel like we're having a huge disconnect today on that. I'm happy to type them.
Yeah, typing them would be great, actually. Thank you.
Sure.
Oh, okay. So the ones with the x minus would be the first two.
Okay, I agree. So that gets rid of these two. All right. This next thing is an amplitude of 3.
Okay.
Right. So what I think would be best here is to have you graph both of these and just tell me any differences you see. Now be very careful. There's the main difference is there's a plus there, and there's no plus on this one. Why don't you graph those and just say, okay, this is what's different between them.
All right, let me graph this. So when I put these two in the graph, they're just a big old squiggly line. Did I type something wrong?
Nope, nope, but there is a difference. Like there's at least one or two things you can say that's different about them. They're not the same. It's like saying everyone looks the same. We don't all look the same. We have differences. Just
I can't tell the difference. Well, I mean, the difference is with the two um problems is that one's being multiplied while one's being added before.
I'm not talking about the
Oh,
numbers, just the graphs. So
oh,
I'm graphing them now, and I mean this is one of the like things that I feel like there's something missing, because like here's the graphs, and you're telling me like here's what I heard. You could say I'm wrong, and that'd be fine. You said these are the same. They're squigglies,
yeah,
but
there's
but
probably
but they're not the same. Like they don't overlap. They're not they're taking up different space. Like there's differences. Imagine you were to go hiking, or I don't know if you've ever been on a like a treadmill setting where it's got kind of like peaks and valleys. Um, there's differences. I mean, or if you've ever been to the ocean, these are waves.
yeah.
You were so you can't tell me that they're the same. There's differences. Give me just one thing that's different about them.
Well, for me, when I graphed them, they both were overlapping each other. They were the same, so maybe I wrote it's
Okay.
different.
So again, with Desmos, you just write it exactly the way it's written.
Yeah, that's what I
Notice that I didn't add anything. I didn't take anything away. I wrote it exactly the way that it is written. I'm gonna snip in these problems here.
yeah, I did the same thing too, but I don't know why mine's like just on the same line. Maybe I did something wrong. Hold on. Sorry, my mom came into my room.
No problem. No problem. I mean, just this is important. That's why I'm trying to. The reason we're doing this is like when you do ice skating, figure skating, and like if someone were to watch you versus someone else, they might not notice much of a difference. But if you were to watch yourself versus someone you really wanted to be like in terms of figure skating, you would say, oh, they do that thing. That's just a tiny bit different. Their body moves slightly different, or their skates. Like there's noticeable differences. And and there's clear differences between these. And that's what I'm just trying to get you to give me a few words to that. And like you said, maybe you just graphed it wrong. Notice there's a plus here, no plus here. Other than that, they're exactly the same. So it's okay if you just want to look at my picture here.
Yeah, I'll
I
look
just
at
need a
yours because I don't know why my Desmos is acting like that.
I just need a few words to show that you understand what a key difference is between these.
The difference is, well, one of them is more, well, kind of, I don't know how to say it. One of them is with the squiggly lines, one of them is more like stretched out,
Yes. The
while
purple one
the
is
other
more
one
stretched
looks like,
out. Good.
one looks more like mountain peaks, while the other one looks like, I don't know, like just from like just reminds me a little bit of a wave, just a little bit.
Okay. Now we talked about this a little bit ago. They don't overlap.
Yeah, they
They
don't.
don't overlap. Okay. And one reason is because there's relative to one another, one is above, one is below. Which one is above and which one is below?
Below is on top, I think it's the +2, and below is just the
The
whole
3+,
one.
yes, the
Yeah.
3+ is above. Yes, that's good. Okay, now that's really important because that's enough information to answer the question now. and we'll do that here with through some process of elimination. So we've already gotten rid of these two. So the 3 plus is a move up, called a shift up, while the 3 is a stretch. Okay. Now an amplitude of 3 refers to a stretch. So which would be the correct answer?
Um, it would be the first one.
They're both stretches. It's looking for a stretch. That's the stretch. Yes. All right. Okay. So new question. I think another thing that's really challenging about these is that they move around. There's no like, okay, it's we factored and foiled and but we're moving all over the place. It really is a general knowledge. So okay, let's look at this new problem here. It says let f of x equal 1 over x minus 3. All right, and g of x is the square root of x plus 5. So let's just look at f of x. Start with that one. Could you go ahead and graph this for us, please? And you can use y instead of f of x, or you can just type in 1 over x minus 3.
All right. All right.
All right, so your graph should look something like this. Does it look something like that?
Yeah.
Great. So the first math commandment is that thou shalt not divide by 0. Division by 0 is very bad in math. It just doesn't exist. So for what number is x minus 3 equal to 0?
Okay.
Could you
So
could you solve this equation for us,
yeah.
please?
So we're gonna add 3 to where 0 is. That's gonna be x equals 3.
Yes, and the oddity here is that it really means that x cannot be 3. You can't divide by 0. That's very bad. All right, now let's look at g of x. G of x is the square root of x plus 5. So will you graph that for us, please?
All right. Now that one curves.
Yeah, it starts over here at -5 and goes to the right like that. Okay, so the second math commandment is that you're not allowed to take the square root of a negative. That's bad. So what that means is you set the inside part of the square root greater than or equal to 0. And we did do a little bit of this when you're doing composition, domain, and range. So this isn't too far outside of realm of possibilities here. So to solve this, you subtract 5 from both sides. X greater than or equal to -5. All right. And so here's what that means. It means that if I were to draw a number line, I were to go on forever, right? Minus infinity to infinity. I have to start at -5, but I can go to the right forever. Is that okay?
Yeah, that's okay.
Okay. So we start at -5, we go to the right forever. That's really good. Then we go back to this previous one, but what can x not be?
X can't be 3.
3. So we have a problem at 3. Problem at x equals 3. So there's actually a circle here because it cannot be 3. So it's everything up to there and everything to the right of it. But at 3, it's a break point. So the way this is written in interval notation is you start at -5. You're like, okay, I'm good, -5. I can go to 3, good. Then 3 to infinity. So start at -5, go to 3, 3 to infinity.
Mm-hmm.
All right, now I'm going to snip in the answers here. Just have you tell me which one is correct based on that, please.
Okay, it would be the second one.
This is the second one, good. All right. Here we go. Right, so this is also kind of a geometry problem, kind of algebra too, like a little overlap between them. All right, so it says the figure below shows part of a stained glass window depicting the rising sun. Which function can be used to find the area of the region outside the semicircle, but inside the rectangle? So they want this area outside the semicircle. And so what I like to do here is I actually like to draw the composites, but separate them. So this is a rectangle on the left, W and W plus 5. We could even label them. Okay, that's a rectangle, that's a circle, semicircle. Okay. This is W down here. All right. Now to find the area, you have to take the area of the rectangle and subtract the area of the semicircle.
Um,
All right. Is that okay? Clear so far? Like conceptually, big picture?
yeah.
Okay. Do you remember the formula for the area of a rectangle?
Isn't it length times width?
Yes. So in this case, it's W times W plus 5. All right. Now the area of a circle, the area of a circle is pi r squared, but you don't have a whole circle. You have a semicircle or a half circle. So you cut it in half, put it in half. All right. But you need the radius. You need the radius thing. The diameter is W. Do you remember the relationship between the diameter and the radius?
Isn't the diameter the line that goes through the radius?
Well, there's a radius goes out from the center to the edge, and the diameter goes all the way across. So the diameter is how many radii?
Like 2?
2, 2r. Which means that if you want the radius is 1/2 the diameter.
Mm-hmm.
Okay, so this one's fairly complicated. In your problem, the diameter is W, so the radius is 1/2 W.
Mm-hmm.
Okay, so the way this works now is you put that formula into the radius, 1/2 W squared. So I'm using this formula up here, putting 1/2 W in for R. Okay, so so give me a little help here. multiply W times W and W times 5, what does that become?
Like W squared plus 5W.
Good. All right, now on the right here, we have to multiply 1/2 W times 1/2 W. So what is 1/2 times 1/2? Start with that.
What is W plus what?
Let's do the 1/2 times the 1/2.
Okay. That's gonna be that's gonna be 1/4
1/4. And then what is W times W?
W
W
squared.
times W squared, good. And we have this pi over 2 out in front. Okay, so notice that multiplication still got to keep going here. So 2 over 4 on the bottom is 8. Okay, so it's 1 over 8 pi W squared, just rewriting that.
Okay.
All right. So now we can look at the answers and see which one matches up. Here you go.
It would be the third one. The third one's the answer.
Pretty tough question, but did great on that. All right, new question here. All right. So it says given f of x equals x plus 1 and g of x equals x squared, what is g composite? That little bubble there means composite. What is g of f of x? Okay. What that means is you take the f of x and you put it in for x, wherever you see an x in g of x. So it means x plus 1 squared. You're taking this x plus 1 and putting it in for x. Okay. Is that all right so
Yeah.
far? Now, to expand this, you have to be careful here. You can't just leave it like that. You have to write x plus 1 times x plus 1. Could you FOIL that for us, please?
Yeah, sure, I can FOIL that. X squared plus 3x is the final product from the foiling.
So we did one of these earlier. Remember, it's first times first. That's x squared.
Yeah.
Okay. Then x times 1 is
X.
1x
A 1x. Oops, that's where I messed
plus
up.
1x plus 1. So try that one more time.
Yeah. X squared plus 2x plus 1. There we go.
Okay, x squared plus 2x plus 1. And one of the things that makes this assessment really challenging is that even though you've done that correctly, they put the answers kind of in a, it's almost deceptive here. Let me slide this up here. So tell me what you see here. Do any of these match up with what you've done?
Wouldn't it? The answer would be the second one, no?
That's right, yeah. So they actually didn't want you to expand it. Sometimes they do, sometimes they don't. I don't know. Don't know what to think, but that's that is that is it here. Okay. Um, here is a new problem. They are getting more difficult, probably because they're all been answered correctly. So, all right, it says, what is the fourth term of the expansion of 1 minus 2x to the n if the binomial coefficients are taken from the row of Pascal's triangle as shown below? So there's a lot in here. How do we even want to start this? So you're first supposed to start with, okay, this is what Pascal's triangle is. Have you seen this before with the ones going down the side?
Uh,
It's okay if you haven't.
I think I've seen it. I just don't remember if I did it.
All right, so the way that you get the numbers, besides the ones on the outside, is you just add. So like 1 plus 1 is 2. So 1 plus 2 is 3. 2 plus 1 is 3. And you always put ones on the outside. So now it's 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And notice there's kind of a nice symmetry to this. You also get this where it's 1, 2, 3, 4. 1, 2, 3, 4. There's some patterns. 1, 5, 10, 10, 5, 1. So notice you're just adding each time. So could you give me the next row, please? Remember, you're just
Sure.
adding, adding.
So it'd be like 15, 20,
You got
15.
it. You got to start with 1, 1 and 5.
1 and 5 is 6.
Okay, now 15. Keep going.
15, 20,
20
15, and then 6.
and then 1. Good. Okay. Now, what's a little awkward is they actually starts at row 0. So this top one is row 0, 1, 2, 3, 4, 5, 6. So this is the 6th row. And this corresponds to the polynomial of power 6. So actually n is 6 in this problem. Is that okay?
Yeah.
All right. Now, there's so much to do to just answer this problem. I just can't even believe, I mean, what they're doing here, but that's what they're giving you. So we'll have to do that. So the way that what they're asking for the fourth term, this is the first term, second, the third, and then the fourth. So it's this one right here. Now what that means for your problem is that it is minus 2x to the power of 4 times positive 1 to the power of 3 times 20. Maybe they are doing it backward. Okay, let me back up here. That's not what they want. They're doing it backwards. So let me switch this up here. 1 to the power of 4 minus 2x to the power of 3. And then you multiply it by this coefficient of 20. So I know this was not clear, but just follow along here. 20 times 1 to the 4th is 20 times 1. Now, negative 2x cubed means negative 2x times negative 2x times negative 2x. Could you simplify that for us, please?
Sure. So 20 simplified. I think. Hold on.
Yep, negative 2 times negative 2 times negative 2.
That'd be like positive 8. No, wait, hold on. No, that'd be negative 8.
Negative 8, and then x to what power? X times X times X.
So -8. Now what?
What is X times X times X?
Oh, x times x times x. That's gonna be x cubed.
Okay, and now we're gonna multiply this by 20.
Okay,
What is 20 times -8?
that's negative 160.
Negative 160 X cubed. And you'll notice that that matches up here with our first answer. All right. We are going to stop there for today. I'm going to go ahead and stop the recording.